this one says find the component form. What is component form? Well, component form is when you have this. Okay, and a while back we said, so that would be like the magnitude, and the x is always cosine theta, and then it would also be the magnitude of your vector. Your y would be sine of theta. All right, so that just gives us a little bit of background. So do we have direction and do we have a magnitude? We have a direction and we have magnitude. So I'm going to just plug those in. So the magnitude is 6, and then cosine of 115 degrees. Then here, my magnitude is still 6, sine of 115 degrees. So that has kind of been in other videos, but I think we can just start here and say, okay, this is, got it. Now I pull out my handy dandy calculator. And so I'm going to do 6 cosine 115. Okay, so that portion is negative 2.536. Negative 2.536. So that looks a little bit ugly, but that would make sense when you have an airplane flying in some direction. Like it's going to look a little bit funky. Okay, and then I would go over and do similar, but now I'm going to do 6 sine 115. Close the parentheses, and that gives me 5.438. 5.438. 5.43. Okay, so that is the component form. And really what that does is that says, okay, here's what, so if I had this just tells me, oh, that is super ugly. That just tells me where this arrow vector is going. So it would be like right, okay, that makes it straight. And so then I'm going to grab an arrow and I'm going to make it, I don't know, let's make it red. And if I do that, then it's starting here and it's going to go negative and then up. So this looks something like that. And it tells me where it is going, so that gives me a direction of 115 degrees. Oh, that makes sense. And magnitude 6, so this tells me like where exactly is the ending point. So if you heard that, my kid's going to work. All right, let's see. Now, let's put all of the things together. Okay, find the component form of the vector that represents the velocity of a plane descending at a speed of 100 miles per hour at a bearing of 120. Okay, so we need to stop and do a little bit of talking about bearings. When you have a compass and you're looking at bearings, which way does the compass always go? Yeah, and if you have a compass, it always, like you always reference everything off of north. So there we go. So generally, we have been referencing off of kind of east. And so I'm going to say, okay, north is this way. And then it says a bearing of 120 degrees. Okay, so what we have to do is basically I start up here and I go 120 degrees. That's right there. Okay, if that's the case, then this right here is 30. Because I've got 90 here plus 30, that gives me, those together give me 120 degrees from north. Yes? So I'm actually kind of going, I would say east by southeast, but it's a little bit south of east. Yes? Okay. So now I'm going to use that. I'm actually, so now this 30 is hugely important. So I want to get to this. It's 120 from north. However, the number that I'm going to use is going to be 330. If you're like, what? Why 330? Well, because if I started, remember when I started off of east and went all the way around here. So there's a difference between like what I'm looking at on the unit circle and what the compass says. So I have to like do all of that translating in there so I can get 330 is what I want. Okay, so here, this is what, find the component of a vector represents the plane descending. Okay, so that makes sense that here's the angle, 330. It's, you know, the plane's going, okay. So, bearing of 120, speed of 100 miles per hour. Okay, so I'm going to go to my component form. The magnitude is 100. Then I do cosine of 330. 100 sine of 330. Okay, float. So 100 cosine 330. So 86.603. 86.603. And then I bet this one should be negative. Let's see, 100 sine 330. Negative 50. Oh, that's kind of nice. So what that means is, see this purple right here, that line? Like this dot right here, like where it ends is 86.603. Negative 50 on the graph. So that's kind of what the plane, that's what's going on with the vector of that airplane.